Well, our next talk was supposed to be by Nichole Calle, but unfortunately she can't join us today, and Lowell has graciously taken over this presentation. They're part of the same lab, and the title of her talk is Analysis of Macrophyte and Invertebrate Epifaunal Assemblages in Deering Estate, Biscayne Bay, Florida.
Hello again. So this work was done from my undergraduate mentee, Nichole Calle. She has been a wonderful undergrad working with actually my more dissertation relevant work on marine macrophytes and vertebrate epifaunal interactions. She was a McNair scholar. This past summer has helped me analyze these sort of basic interactions. She is also sick, and so if anyone here knows Nichole Calle, please give regards, and hopefully she'll be better. So of course, this work has been supported by McNair, but also additional support from Deering Estate, Durham, and Crest Cache. So let's jump into it. So it's not too long ago where I talked a lot about the macrophyte communities in Biscayne Bay. But I will say what little we know about the macroalgal communities, we know even less about the associated epifauna. At least from the literature that I have examined, there has not been any sort of survey, at least to my knowledge, correct me if I'm wrong, of invertebrate epifauna done within the last 40 years. Some of the work done includes McLaughlin when she was, where they were looking at Thalassia restoration or Turkey Point, as well as Nelson, where they were looking at comparative epifauna communities between Miami and Nova Scotia. So just by virtue of these little sea bugs, as I like to call them, there is a potential opening to incorporate epifauna into monitoring and education programs. And so for those that are not too familiar in my work, I look at interactions between marine macrophytes and invertebrate epifauna. As you saw in my last talk, macroalgae come in all shapes and sizes. And because of that, they provide diverse architectures, which provides diverse biogenic habitats that can maintain high species diversity. And in turn, these epifauna would take advantage of these macroalgae as food and habitat. And through that, these epifauna can maintain essential trophic and ecosystem functions. Some of these invertebrates are grazers, such as the isopod Ericksonella tenuata that would graze on the epiphytes of seagrasses to maintain a healthy system. Others, like snails and amphipods, could be detrital feeders, which feed on the dead organic matter and basically recycle all those nutrients up the food web. These crustaceans and mollusks can be food for larger predatory fauna, such as fish that could be of commercial or recreational importance. And some of these invertebrates can serve as indicator species. These lovely amphipods right here have previously been recorded to be good indicators of oil spills. Dixon Host has found that the bivalves, Brachydontes excitus, tend to favor or at least occur in higher abundances during high salinity events, at least in Texas. And so given how this is primarily undergraduate driven work, I have taken a very simplified approach to understanding the biotic communities in Biscayne Bay. We are particularly interested in what habitat forming marine macrophytes are found between sites at Deering and compared to epifaunal diversity between macrophyte habitat and sites. So unlike the 9 sites, we can only find these red macroalgal mats basically in zone 3, which are the offshore systems. And so you can see that we try to incorporate variation in the substrate as well as distance to shore. So we have at least 2 to 3 sites that are seagrass dominated with 1 additional rockery site next to a mangrove, and also has a mixture of seagrass and macroalgae. At each of these sites, we have collected 5 seagrass and macroalgal habitats, giving us a nice sample size of 40. And to control for sampling date, all of the samples that we analyzed were collected during March of 2018. So something they want to see here. So we found quite a bit of macroalgae. At least 4 of them were considered mat forming. And if I can show some pictures right here, some of the algae like Laurentia, Digenea, Ectophora, what they all have in common is that they kind of have these weird corticated branching patterns. And so we are suspecting that these increases in branching can provide nice hiding spaces for these epifauna. If we look between the three sites, we didn't collect any algae at site 12, unfortunately, but we have found site 3 having the most forming macroalgae, whereas site 6 and 7 have some variation in the algae that have been found. Which is really interesting because in the previous talk, I've shown that if you incorporate Deering as a whole, again, the issue of scale here, 3, 6, and 7 all are supposedly similar in the macroalgal assemblages. Moving on to invertebrates very briefly, we looked at the invertebrate fauna and counted them, identified them to broad taxonomic groups, as well as counted them for abundance. So for the next 2 slides, I'll be talking a little bit about the richness and the abundance. So this is the result of the every 4 sites, as well as the average taxon richness of the invertebrate epifauna between benthic seagrasses in the green and the red macroalgae in the red. There is a very consistent pattern of finding more richness of invertebrates as compared to seagrasses, regardless of where they are site-wise. And this is very consistent with other, albeit very older studies done in Tampa Bay as well as the Indian River Lagoon. When we look at abundance, the picture presented is very different. So you can see that a considerable variation, but as you can see, this big old honking orange bar that you see here shows that there is much higher average abundance of epifauna found in the macroalgal mats of the rockery site compared to all the other seagrass macroalgal combined sites. And this is really interesting because even though we are doing preliminary analyses, what we have found qualitatively is that a couple of things. One is there is a dominance of epifauna dominated by the bivalve Brachydontes extracheus, particularly in their larvae form. And even though I don't have nice pictures of here, because site 3, the rockery, has a rockery site, in other words, the substrate is rocks as well as next to a mangrove island, we do suspect that at least one, if not both of those factors have contributed to this high abundance. If you think about it, the mangrove island is a nice perching ground for birds, and birds like to poop, and so that could be a nice source of nutrient input. Alternatively, because you have the rockery substrate, it allows some of the macroalgae to have available substrate where they can pretty much develop into these larger mats. Yeah, so very briefly, as far as conclusions concerned, if your invertebrate epifauna in red macroalgal habitats tend to have higher richness, and depending on the site, have higher abundance. I really do think that if anything, there needs to be more work done on these macrophyte epifaunal assemblages. And I do, even if it's very brief and very superficial, kind of see adding on to my early proposal of a citizen community-driven monitoring program by these, looking at both the epifauna and the macroalgae. And so something I want to bring up, in addition to the macroalgae, I would also advocate for including epifauna into a potential citizen or community science-driven efforts. And working with Deering for a while, I have found that K-12 students are particularly excited when they see things move in the macroalgal mats. For those that are more pedantic on what could be suitable indicator species, these are a few that I think are common, abundant, and easy to identify, which are some limiting factors related to indicator species. If you're looking for previous evidence of what these invertebrates can indicate, again, amphipods were found to indicate damages done to oil spills. Relevant to Deering's restoration program. So there was a previous study done by Dixon Hoes who has found that Brachydontes found in higher abundance during high salinity events, whereas this isopod Ericksonella attenuata are more abundant in estuarine conditions. But again, there is a lot of work, let alone recent work, that needs to be done in assessing what is epifauna and how do they fit within the greater context of Biscayne Bay as well as the shallow coastal systems. And this work have not been done without funding sources that I mentioned earlier, as well as the work of undergrads that have helped over the years. And I'll take any of y'all questions related to this or the previous talk.
Thank you so much, Lowell. I found it really interesting that you're seeing a lot of the the epifaunal community near the rookery. We've anecdotally seen an increase in mangrove terrapins, which is a turtle, or one of the rarest turtle species found in Florida. And we've seen, I believe, about 3 nests that have never been documented before, at least in the past 30 years. So I'm very interested to bring you in, maybe with other partners at Pelican Harbor Seabird Station who are interested in those terrapins.
Thank you.
Does anyone else have any questions?
I have 2 questions. This is Dallas. I think I heard you say that your monitoring ended in 2019, and I wanted to just confirm that because I was curious if you were still monitoring. And then second was, did any of your, the timing of your monitoring coincide with the start of dry season and when the pumps start running?
Yeah, so what I was about to say here. So the Deering project has pretty much ended in 2019, unfortunately, but last year I had to collect samples for my more invertebrate related project. And so that's why, for example, I was able to see, the green filamentous mats that were coincidental during that wet season last year. As far as sampling day is concerned, I'll have to reiterate, there is a trade-off of having a primarily undergrad-driven project. During the summer, usually a lot of undergrads, they have summer school or are very occupied with other things. So unfortunately, we don't have much data related to the start of the wet and dry season. But that's all the more of maybe not so much of being primarily driven by the lab, but through a collaborative approach, we can start thinking about how even having a very brief and superficial monitoring effort can help provide insight on what's happening in the bay, because that is really important.
Thank you.
Well, thank you so much, Lowell. We had a great morning session of talks. We are going to go into lunch. Let me pull up the schedule. So if everyone can be back by 12:45, it's the same link that you used this morning, and we will have the afternoon talks. And the first talk will be by, if I can get to the next slide, will be by Jennifer Posley with Fairchild Tropical Botanical Garden. So that will be at 12:45. See you guys then. Enjoy your lunch.